Hello everybody, Brian here from quantlabs.net. Okay, so it's been a while since I've done anything technical. Let me just show you what we've been working on since last set of videos at my YouTube channel at QuantLabs. So if you go under the video tab here, you'll notice here that I've been testing about a week ago, testing various technical indicators. ADX, Hilbert transform, Williams R, stochastics, and those are the ones that I've been testing within the J4X visually to see which ones produce reliable, well, I shouldn't say, reliable, but how I define reliable is where the indicator of movements in a different direction are not lagging. So the ones that came out, and this is for tick and 1 minute data. So the ones that did well were Williams R, the stochastics. Hilbert transform was okay, but these two here were really good. So I'm going to test that in another library. So knowing that the ones that I was using, like linear regression, were just too choppy, and in my mind, looking at the charts as an indicator for entry and exit positions, it just was not really reliable. So all these other ones that I've been working on since, let's say, December, just was not as effective as if I'd used maybe these other ones. But again, the way markets work, they may not work as well, but they just seem to be more reliable, meaning that they are not lagging. Okay, so what I've done also is I've taken out all the processing out of the J4X, meaning all the trading logic has been moved out of the J4X. So it's now been put into Python scripts. How do I do that? I've talked about this before where I use Redis. So if you go under the playlist, there's a ton of videos on Redis, the NoSQL database. This is what I've been using for many years. It's been very, very reliable. So you can go through all these videos and see how I'm using that. And where's my videos here? Hang on here. Where are you? There we go. Okay, so that's where I've been using the Redis now for years as my central data hub for everything data-wise. So if you go back into my lists, all of these indicators that I've used here. Now, if you are listening on my podcast with the audio only, you want to look for my videos under the Quant Labs YouTube channel, testing ADX and Hilbert transform for reliable Forex trading indicator. The other video I'm mentioning here is Williams R and Stochastic's best indicator for low time frame Forex trading. Okay, so those out of the way. So going back is using Redis as a data hub. So what I've done now within my J4X is I've pushed the raw data into either my database using Redis or CSV. Now you could also do the same thing using socket programming. So if you go under my playlists again, if you look up under Dugas copy now, we've got quite a lot of videos there. You'll find
Brian here from quantlabs.net.
a lot of videos and example code on how to do all the different things I'm going to mention here. So what I'm referring to is basically...
Hey there, how's your trading going?
Okay, so that's basically what I'm doing is I'm pushing all the market data out of J4X, and that's potentially live, even though I'm using a demo account, pushing that data into Redis. So using Redis, you can use any programming language that binds with Redis. So I've shown demos in Java, C++, Python, and even .NET languages. So that's what I'm doing there. So I'm pushing all the raw data that I need, which is open, high, low, close for the minute data. I don't really care about Forex data, tick data. So I'm just pushing minute data into this database. And the best, the most reliable way is to actually use scripts that you could use. So if you go into Google and do a search for J4X API Examples, actually, let me rephrase that, probably Dukas copy J4X API Examples. And in there, you will find these examples here for that. So what you're looking for under this section here, under strategy examples, is things like historical data, right here. So how to work with historical data, because even though let's say you have a tick or a minute bar or even any kind of bar, and anything prior to that's considered history. So do remember that. That's how the language is when it comes to Dukas copy. So the best thing to do is, what do you want to do with that data? So in my case, I think it's under practices here. So if you go under practices, under strategy API practices, you're going to be looking for different ways to look for the data that you want. Data from CSV, to save the data to a CSV. You can also use these socket connectors as well. Write bars in CSV or a file, or to a DB or database, which is MySQL, CSV, or Excel if you want it as well. There's many different options. So I choose to write bars to a CSV and then have a Python script that will keep an eye out for changes in a folder under CSV. So what I've done here is, I know this is very generic, what I'm showing you. If you think, to be honest, I can't even remember the, oh, here we go. So I have here on my Mac here, I have a folder called CSVs, and the comma separate value files, the various different currency pairs that I want. So in this case, for this currency pair, let me just load up a proper, let's do LibreOffice. So it's loaded up as a comma separated, as a spreadsheet. So here we have the pair name, date, time, open, high, low, plus the volume. So that's the standard format. So I have a script, a Python script, that will look for these changes and then push every line that comes in at the end of each file, and then push that data into a Redis table. We can easily check that out. Just pull up another terminal here. Now again, remember, I'm working on Mac OS on a Mac. So in my case, I'm pulling up Redis server. So here's the Redis server. Now, hopefully you know about this program that I am using called RDM, or Redis Desktop Manager. And what this does, it will enable you to see the data. So here is the raw data I speak of. Okay, so the key is the Euro, New Zealand, whatever, and then the values that I want right here that are separated again by comma. Okay, so do remember that. And I also, actually, no, I've got a database here called Forex Data. This is the more up-to-date one that I've just made changes to. So essentially what we have here is, there's different ways to go around doing this, but in my case, I'm keeping it simple for now. We have the currency pair plus the time and date right here. I'll separate by comma, and then again we have the open, high, low, close, and the volume. Okay, so that's how we are able to keep track of the data. Now I could break out and architect the database in a smarter way, but that's how I'm doing it right now. This is with the new strategy, as I said. Okay, so that's basically how I'm doing that. Now that we have the ability to work with the Redis database and the Redis server, yeah. All right, so that brings me to the next big question of the TA-Lib. The TA-Lib is my new way of calculating technical analysis. So I just want to show you how this works. The TA-Lib is a C++ library that is for technical analysis. It includes a ton of indicators that you would get in a typical trading platform. All these, the EME, WMA, blah, 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 all, I don't know how many there are, but there's enough in there to keep you busy. Now, in my case, as I said earlier in my previous video, we are only interested in two, Williams %R and stochastics. My case, I'm looking more for the fast stochastics. I'll let you look those up. Those are two that I'm looking at as indicators. And it's kind of this strategy that I'm working on is more of a scalping strategy, but I can easily slow down and control the frequency. So I could go from a minute to 15 minute, 5 minute, an hour, whatever. So it's just a matter of changing the data that I push into Redis and the data and then those CSV files that I mentioned earlier. So that's essentially the TA-Lib. Now the TA-Lib, the original, this one we're talking about is a Python wrapper for TA-Lib. Now TA-Lib is here, and it, as I said, it's an open source API for C++, Java, Perl, Python. Okay, so it's a pretty sophisticated technical analysis library. All right, so knowing that we have the TA-Lib, here's all our indicators and decent explanation of how these work. So to implement these, or to get your library or your installation working, there's a variety of things that you need to understand. So you can use pip install TA-Lib as I show here. But there is a dependency you have to put in, which is a TA-Lib itself, the TA library. Okay, so for Mac, you have to do this. Just brew install TA-Lib and install it, and then you can see the steps involved with Windows and Linux. Okay, and then from there, once you have that dependency, and you can do the pip install TA-Lib. That's all explained here in the TA-Lib GitHub repository. All right, so knowing that, let's go into Python now. So this will work with both work with Python 2 and 3. I'm right now just playing around in Python 2, 2.7. So there is some example code here once you get the TA-Lib installed. Right here, there's various ways of going about this. So you can use Numpy, and let's get the interpreter running. So you can see it's 2.7.13. So we can do an import Numpy, import TA-Lib. Okay, and then let's create some random values. Oops. And then just do a standard SMA on those values. And then just print out output. There you go. Okay. So you can do the same thing with Bollinger Bands and so on and so forth. But let's get a little more sophisticated. Let's do this guy. Oops. Oh, we didn't want to call the NSA there via Skype. Those fat fingers in action again. Okay, so now what we're going to do is we're going to create this array of inputs. As you can see here, we're creating random 100 each for open, high, low, close volume. Okay. And then from there, once we got everything working, so we're going to skip down to this function and do an abstract import. So here, let's do the SMA again, setting the time periods of 25. Now, just to save you some confusion, let's do SMA. Just want to show you the signature of the SMA. Okay. We could do one of these things. TA-Lib SMA. This one right here. I know. I think if I go into here, okay. So what I want to show, let me do a better search here. Williams R. Okay, yeah, so I'll show you. So we'll go back to where we were, and let's print out output. As you can see, here's the SMA for those 100 arrays. Now, one thing I want you to be aware of is the required number of data points you need to start seeing before you get actual data. In this case, we have 3, 6, 24. So we need to have at least probably 25 elements in this array before I'll start pumping out data. And from my earlier tests, you need more than probably at least 25. Okay, so let me show you another example here. All right, so if you follow through the GitHub repo here for TA-Lib, you will notice, so we've done these inputs, and then we come to our stochastics. Now, here is where it gets interesting, is the inputs. So if I go back to my signature, let's see if we can find it. Here we go. Okay, so here's our signature argument list that we need for setting up this stochastic call. You'll notice here we have high, low, close, then the parameters of fast K period, slow K period, and so forth. This is where it gets very interesting, high, low, close. But in this case, what we're doing is we're able to just provide the inputs, which is basically a breakdown of open, high, low, close. And we can just basically default to here the high, low, close by default. So I want you to be aware of that. Okay, so if I do this, and I go print slow K and print slow D, which is the returning results for slow K, slow D, we get data. Right? Now, here's where it's interesting. We can provide the inputs data, the input defaults for what it needs, but we need to default to these to specifically say we will only want to use HighLowOpen. So if we go back to our parameter list here, argument list, it doesn't say anything further about that. So call it a mystery or whatever you want. But let's just see if we can get more detail on that. Yeah, I don't know. Anyways, so be aware of that. Okay, so going back to our TA-Lib here. So we have stochastic inputs, but we're setting the prices of high, low, and open out of this batch. So we're using high, low, and then open. instead of defaults of high, low, and close. Okay. So how would we work with the Williams R? So if we look at the signature for Williams R, all we really need to define is this time period. Okay, now remember, these are just random numbers, so they're going to be kind of screwed up. So if I just do this, will R, oh, and we got to put in the capitals, will R inputs, and then time period. I don't think we even need to put that in there. Okay, so we'll use the default of time period of 14, I believe. So there you go. Those are the return data. So in this case, we need 4, 8, 12, 13 for it to start generating numbers. Okay. So again, remember, this is assuming it's 14 days, and we get all these wonky numbers here. So if I go, but set the parameter of time period of, I don't know, 0.025. Let's see if that'll take. And does that make a big difference? Not really. See here, 511, 271, 271, last 900. So it didn't really change anything there. So, but that's a lot of experimentation. But I just wanted to show you the usage of this Python interpretation or implementation of TA-Lib. Very powerful. A lot of people use it. The other thing you need to be aware of is the files. You can see here, as I keep referring to the most recent up-to-date 3 days ago, so it's fairly up-to-date. Because if you go Google, there's a trick here that I've used for something else. So if you do a Python TA-Lib, there is another project in there. Has not been updated in 2 or 3 years. So just make sure you want to use something that's fairly up to date. The big takeaway is the last number of changes, and you can clearly see that it has been updated. So you don't want to use one of those abandoned projects at all. Okay, so that's TA-Lib, and hopefully it'll help you out later.